Sound check. Chewbacca says. Okay. Hi. Thank you. Okay, so the thing you should know about 11 is this is the stem of a, quote, denuded, multiple choice question. Don't get too excited. That's exactly what it says. Okay, so the premise of the question is to assess whether you understand the, I don't know, whether you understand the rules for simplifying integrals. Okay. So, a couple things. Number one, you can separate addition and subtractions.
What do you mean by separate?
Number two, you can factor constants. Yeah. Number three, you cannot separate a multiplication of functions, i.e., there is no product rule. Okay, very important. There is no product rule for integrals. Oh, out. Any answer choice that follows the rules is the answer. There will be only one.
There's no product rule for.
Nope. Okay, so Ed? There is only one that will work. In the words of Christopher Lambert in The Highlander, there can be only one. Cue the Freddie Mercury, yeah.
So can you go over why the one in the back is the answer for the one in the front?
Well, it's the answer choice that was correct. Okay, so let's touch on that. The answer choice, or the answer in the key, is the correct answer from a multiple choice question. Okay. It is one of many possible correct answers. Okay. So just to kind of be clear about what happened, number one, we took that integral, integral of f of x times g of x minus 7hx minus g of x again, or f of x? G of x. Okay. Dx. We took that and we separated it into these two. Integral of f of x, g of x, dx minus integral of 7hx plus gx dx. And then we factored out a 7. See, you always want to talk before I finish. It's a plague, I tell you, a plague. Minus 7 integral hx plus 1/7 gx dx. Again, this is just one of many possible correct simplifications. This is the one that happened to work. So when you get to this question, if this question's on your test, make sure you peruse the answer choices before you start working. Okay? Special note. Do not separate.
In those kind of functions, do not separate the terms.
Yeah, the factors. I'm trying to spell separate, sorry. Did I spell it right?
Yes.
Yeah.
Would you ever be able to leave the dx at the end and not factor it in? Like if you just left brackets around holding the dx at the end?
Every integral needs a dx. Yeah.
So, f of x g of x minus the one before the last one.
Uh-huh.
If that was on the multiple choice part, could that be an answer?
That could be a correct answer, yeah.
Okay. So whichever one.
Whichever one.
Oh, okay. So it could be any part of the simplification process as long as it's.
Yeah. We could have actually just simplified by separating all three terms.
Oh.
That could work too.
So whichever one is part of the simplification process
Yep.
would work.
Yep.
Okay.
Julia, was that you with the question? No. Oh, Roya?
So if you had another one like this, but instead of like a 7, it was so you have to always factor out the constant.
No, I'm not saying you have to always factor out constant. I'm saying you have to look for the answer choice that is correct. Okay. For example, if there was an answer choice that said 10 here, and it was 7/10 h of x plus 1/10 g of x, that was the correct answer. So you got to find the one that correctly is equivalent. Okay. Because of that, it makes this one a little difficult to prep for. Because there are so many different correct answers, I can just show you why the answer that was given was the correct answer among the ones that were not there. Okay, that brings us to 11. That brings us to 12, fundamental theorem of calculus. Again, we want to evaluate from -1 to 1. -1 to 1, I forgot what the function was. Square root.
The cube root.
Cube root of t.
Minus 2 dt.
dt. I want to turn that into powers. That's t to the 1/3 power minus 2 dt. I want to take that and 1/3 plus 1 is 4/3. So 3/4 of t to the 4/3 minus 2t from -1 to 1. Let's see, can I do more here? Yes, I can. 3/4 of the cube root of the 4th power of t minus 2t. Maybe that'll help us out when we substitute. Let's see. That's equal to 3/4 of the cube root of 1 to the 4th power minus 2 times 1 minus 3/4 of the cube root of -1 to the 4th power minus 2 times -1 3/4 minus 2 minus, see, -1 to the 4th power is still 1, so it's minus 3/4 plus 2 okay, 3/4 minus 3/4 is 0. Minus 2 is -4. So -4. Yeah.
This would be a multiple choice question, right?
Mm-hmm.
Why can't you just plug it in and calculate?
You could. You could. But I'm not here to teach you how to do that because you know how to do that.
Okay.
But on the AP test, we won't have.
Oh, there is no way this would be a calculator question on the AP test.
So you could just plug it in.
There's no way this would be a calculator question on the AP test.
Oh, okay. So
This is not a this is not appropriate calculator question. Yeah.
So the fundamental theorem is when you get the anti-derivative and you plug in.
Yes, that's one part of the fundamental theorem.
But to get the answer.
Yeah.
So basically just asking you to evaluate.
Mm-hmm. Okay, let's see. That gets us to 14? No, 13. Okay, and again, I'm going to do this by hand. Is that 6 plus 5x?
It's 5 plus 6x plus x squared.
5 plus 6x plus x squared over 5 plus x dx. And this is kind of like the limit problems where you factor and cancel.
Yeah.
This is kind of the same thing. This is 5 plus x,
Times
1 plus x
over 5 plus x.
dx. That is 1 plus x. Okay, and of course one of the answer choices would naturally be 1 plus x plus constant, or x plus 1 plus constant, and I think you know why. Integral of x is 1/2 x squared. Integral of 1 is x plus constant. Hey, how you doing? Tired?
Were we? Doctors. Oh,
Oh.
you okay?
Okay, that's 13, 14.
That's not the answer to 13.
What's the answer to 13?
10.
Oh, what are the limits?
No, I mean, 5 and 3.
5 and 3?
That's so. I didn't see that.
Oh, there are limits in that. Look at
Whoops. I'm not the only one who missed it?
So then there'll be no more.
So plug it in. Plug it in.
All right, so what is that? 1/2 of 5 squared plus 5 minus 1/2 of 3 squared plus 3. Suri. Get out. 25 over 2 plus 5 minus 9 over 2 minus 3. Was that 16 over 2 is 8. 8 plus 5 is 13. 13 minus 3 is 10. Ding ding. Are we on 14 now?
Yes.
Okay. 14. Is equal to f of x. You know what?
It's 1 plus 2 to the 4th.
How many times that by the
These are t's.
And the x is the x, but
Like that?
yeah.
Okay. We want to find f prime. So f prime, that's equal to didx and I think you know what to do. I'm going to do this very explicitly. I'm going to substitute 1 over, oh, why is everything else slanted? 1 over 1 plus x to the 4th times 1 minus 1 over 1 plus 2 to the 4th times 0. This is the derivative of x. This is the derivative of 2. And then you're going to simplify and you get f prime of x is equal to 1 over 1 plus x to the 4th. Okay?
It asked you for
all it asked for
f
was
of
the
x and
derivative.
f of 2.
Yeah, I know. I'm not finished. Hmm?
How would you do it if there's a like, say there was like x squared at the bottom?
Mm-hmm. You would do it exactly the same way, only this would be still x to the, well, you'd substitute x to the 4th here, and then that would be a 4x cubed. Cubed. The derivative of x to the 4th? Top and the bottom? Yeah. Same thing. Substitute, multiply by derivative. Let me finish this problem and then we'll get to that, okay? Okay, so let's continue here. And we want f prime of 2 then. That's going to be 1 over 1 plus 16, which is 1/17. That's our answer. So remember to take the derivative first. Substitute later. Substitute later. Okay. Let's get to that suggestion. Let's extend the problem a little bit. Extended remix. What question was this? 14?
Yeah.
Extended remix of 14. Okay. So what if we took the suggestion and we changed that both limits like that?
Cry.
dt. And we took the derivative of that. Okay. Okay, so substitute 1 plus x to the fourth times 4x cubed minus 1 over 1 plus x to the fourth times 1, with a special note that this is the derivative of x to the fourth. This is the derivative of x. Mm-hmm.
Why do you take the derivative of those?
That's part of a longer explanation than I think we need to do right at this point. Yeah. So that is 4x cubed over x to the 16th plus 1 minus 1 over 1 plus x to the fourth. You would probably have to combine those together. You know what? But that's not really what we're worried about here. I'm going to worry about the calculus for this question and not the algebra. Okay. Questions on how to do that? Yeah.
Oh, my bad. You didn't make it up. My bad.
And that leads us to 15, 16, 17. I suppose I should do these real quick then. 15. 15. Oh. Let's get this. First one is the left rectangular sum. So my t 330 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 8:30. Delta t 1/2, 1, 1, 1, 1, 1/2. F of t, was it left method?
Yes.
So 76. Help me, 76?
73.
73.
Yeah.
75. 75. 74.
72.
72.
70.
70. 66. Okay, so area, half of that is 36 and a half. 75. 75. 70. 33.
72.
72. Okay, and then the integral from 0 to 5 of ft dt can be approximated with 36 and a half plus 75 plus 75 plus 72 plus 70 plus 33. And so from 0 to 5 of ft is approximately 361. Someone have that?
361.5.
I can't believe I memorized that. Next one is the midpoint rule. With 3 rectangles. Question? Yeah.
What's the difference when you do left rectangle and right rectangle for the values?
The difference is where you evaluate the function. Okay, so midpoint rectangles. Start with T. The first one is 334 to 5. Next one is 5 to 7. Last one is 7 to 830. Our delta T, that's going to be 1.5, 2, 1.5. Midpoint would be f of t. This would be f of 4. This would be f of 6. This would be f of 8. Let's get those numbers. What was f of 4? 75? Great. What was f of 6? 72. Great. F of 8 was 66, right? Yeah.
How do we know when we're supposed to just find the number in the middle, or take the first one and the second one, add them and divide them by 2?
Well, one of those methods is the trapezoid method. The other one is the midpoint method. You have to read and know which one's which. Okay, what was this? 1.5 times 75. I don't remember. 130? No, 112.5. Darn it, I don't have it. Half of 75 is 37.5.
It's 112.5 and 144.
And 99. And then so the integral from 0 to 5 of f of t dt is approximately equal to 112.5 plus 144 plus 99. So it's approximately equal to 355.5. 355.5. Next part of this is the trapezoidal method. Trapezoids. Okay, first. Oh. Bye-bye. Good? Okay. Trapezoids. The first one, integral, or the first is 330 to 4. Then we go 4 to 5. 5 to 6. 6 to 7, bless you. 7 to 8. 8 to 830. Delta t, 1/2, 1, 1, 1, 1, 1/2.
Where did you see 0.5?
Erase. Why won't you erase? Why did that work? Half of f of t1 plus f of tr So this is half of what was it?
Why is it T1 and TR?
TLTR.
Oh, TL.
Yeah. 73 and 75, which is 74. This is 1/2 of 75 and 75, which is 75. This is 1/2 of 75 and 72, which is 73.5. This is 1/2 of 72 and 66, which is 68. Is that right?
No, it's 16.
72 and 70. Which is 71. That's ugly. 71. This is 1/2 of 70 and 66, which is 78. Thank you. 68. And this last one is 1/2 of 66. 66, that's 66. Okay. Oh, right. Areas. Half of 74 is 37. 75. 73.5. 71. 68. 33. And so my integral from 0 to 5 of ft dt can be approximated with 37 plus 75 plus 73.5 plus 71 plus 68 plus 33, and that's approximately 357.5. So that's that. Okay. Let's see, how far along are we here? Oh, very important. Oh, the average temperature. Okay, so the average temperature.
That's the 1/50 minus A.
Temperature, that's equal to 1 over 5 minus 0. 0 to 5. F of t dt, which ultimately is 1/5 of 357.5, which is 71.5
Yeah.
degrees Fahrenheit, yes. And lastly, we're supposed to do this, integral from 0 to 5 of f prime of t dt. Okay, and this is a fundamental theorem of calculus. The integral of a derivative is the function. That's the fundamental theorem of calculus. Theorem of calculus. Yo. F of 5 is 73. No, so F of 5 is 66, right? 66 minus 73. That's equal to -7 degrees Fahrenheit. And you're supposed to interpret that. So don't interpret the integral, interpret the result. How can I best word what this f of 5 minus f of 0 is? Yep. Okay. So between 3:30 p.m. and 8:30 p.m., the temperature in Woodland Hills dropped 7 degrees Fahrenheit. Okay.
Do we have to put this one in detail?
Very understand where you got that
Yes. Questions? We good? Okay, at this point we have question 16 and 17. I feel like we've gone over those in class well enough, right?
Yes.
Yeah.
Yes. So we're going to adjourn here today, okay? If you have additional questions, come see me and we'll help you out. Let me turn this off and then we'll get to that.
What about on the bookwork?
Yeah, we could do that. Huh? We could do that.